Hello, I'm Alex, and I am going to talk about the hyperbola, the equation, and the graph of it. So first, looking at the hyperbola, it is one of four conic sections, and you get these conic sections by intersecting a plane into a conic section, which would be two cones stacked on top of each other with the points connected. And you can, the other things you can get from this is a parabola, circle, ellipse, or of course the hyperbola. And looking at our problem, we know this is a hyperbola because there is a minus sign in front of the x squared variable, and if this was a plus, then it would have either been a circle or ellipse, as we would have found out in solving the problem. And we also know that is not a parabola because we have two variables squared, so this is again a hyperbola. And next, looking at the standard form of a hyperbola, as I have written in the more top right corner, you can see the y minus k in parentheses squared over 2 squared, or a squared, minus x minus 8 in parentheses squared over b squared equals 1. And that is actually the standard formula or form for a vertical hyperbola. And we know this is a vertical hyperbola because it has the y variables in front of the x variables. And you can see, since this is vertical, the u-shapes on the graph are going or facing up and down instead of right and left as they would be if it was horizontal. And if it was horizontal, then the x variables would be in front of the y variables. So next, looking at how we solve this, we first move the constant variable, or the 199, over to the other side of the equal sign, and then next we factor out the 9 and 16 from the x and y variables and do a bit of factoring and get the y and x variables inside of the parentheses with the squared. And then we will move the constant variable back over to the other side so that we have 1 on the right side, as our standard form is. And so we end up with what is in the box, which is our standard form for this hyperbola. And so next we'll start to graph this, and the first thing we do when graphing a hyperbola is find the center of it. And we do this by looking inside of the parentheses of the x and y. So looking inside the y parentheses, we see a +1, which means that we need to go down 1 on the y-axis. And inside the x parentheses, we see a -2, which means we need to go right 2 on the x-axis, which brings us to 2, -1 as our center. Alright, moving on from there, we start to find our vertices, and by doing this, since this is a vertical hyperbola again, we take a and go up and down a units. Now, since in standard form a is squared, we have to square root it, so we square root 16 and we get 4. Then we go up and down 4 units from our center, which brings, we go up 4 units, we get to 2, 3, and we go down 4 units, we get to 2, -5. And those are our 2 vertices. And next we find our co-vertices, which we use to help find our asymptotes. And doing that, we square root 9 when we go right and left b units, and square rooting 9 gets us 3, so we go right and left 3 units. And then we draw a box that connects those 4 points, and from this box we find our asymptotes by drawing 2 lines connecting the corners. And on the left you can see some formulas that I have to find the asymptotes, but you do not necessarily need those. And I also found the foci of the hyperbola, and that is something else added to the graph. So I hope you learned something